Structured cabling system elements. General. The structured cabling system, SCS, shall be designed to provide a flexible, reliable, and high-performance cabling infrastructure to support voice, data, and video communications. The system shall be scalable to accommodate future expansions and upgrades. Structured system cabling design requirements. General. The SCS design shall comply with the latest industry standards and best practices. The design shall ensure optimal performance, ease of installation, and maintenance. Data voice cabling. Data and voice cabling shall be provided to support Ethernet and telephony services. The cabling system shall be capable of supporting current and future network speeds and technologies. It shall include Category 6 or higher twisted pair cables for copper connections and single-mode or multi-mode optical fibers for high-speed data connections. Equipment room shelter terminations. Cabling shall be terminated in equipment rooms and shelters using appropriate termination hardware. Terminations shall be clearly labeled and documented for ease of identification and troubleshooting. Termination hardware shall include patch panels, punch-down blocks, and optical distribution frames, ODFs. Copper cords. Copper patch cords shall be provided for data and voice connections. They shall adhere to the following specifications. Quality and standards. The copper patch cords shall be of high quality and comply with industry standards such as ANSI, TEIA 568C.2, IEC 11-1801, and CNELEC EN 5173. Cable type. Patch cords shall be constructed using Category 6 or higher unshielded twisted pair UTP or shielded twisted pair STP cables. Length. Patch cords shall be available in various lengths, typically ranging from 0.5 meters to 5 meters, to suit different installation requirements. Connectors. Patch cords shall be terminated with factory-installed RJ45 modular connectors on both ends. The connectors shall be gold-plated to ensure high-quality connections and minimize signal loss. Performance. The patch cords shall be tested to ensure compliance with performance specifications, including insertion loss, return loss, crosstalk, and attenuation. They shall support data rates of up to 10 gigabit per second for Category 6A and higher cables. Sheath and jacket. The patch cords shall have a durable, flame-retardant jacket made of PVC or low-smoke zero-halogen LSZH material. The jacket shall be color-coded for easy identification and management. Strain relief. The connectors shall have molded strain relief boots to prevent damage to the cable and connectors during installation and use. Compliance. Patch cords shall comply with RoHS, Restriction of Hazardous Substances regulations, to ensure they are free from harmful substances. Fiber patch cords. Fiber patch cords shall be provided for high-speed data connections. They shall adhere to the following specifications. Quality and standards. The fiber patch cords shall be of high quality and comply with industry standards such as ISO IEC 11801, ANSI TIF 568C.3, and Telcordia GR 326. Cable type. Patch cords shall be constructed using single-mode OS2 or multi-mode, OM3 or OM4 optical fibers, depending on the application requirements. Length. Patch cords shall be available in various lengths, typically ranging from 1 meter to 30 meters, to suit different installation requirements. Connectors. Patch cords shall be terminated with factory-installed connectors such as LC, SC, or ST on both ends. The connectors shall be precision molded to ensure low insertion loss and high return loss. Performance. The patch cords shall be tested to ensure compliance with performance specifications, including insertion loss, return loss, and attenuation. They shall support data rates of up to 10 gigabits for multi-mode fibers and up to 100 gigabits for single-mode fibers. Sheath and jacket. The patch cords shall have a durable, flame-retardant jacket made of PVC or low-smoke zero-halogen LSZH material. The jacket shall be color-coded for easy identification and management. Strain relief. The connectors shall have molded strain relief boots to prevent damage to the cable and connectors during installation and use. Polish type. The connectors shall have a high-quality polish, such as UPC, ultra-physical contact, for multi-mode fibers, and APC, angled physical contact, for single-mode fibers, to ensure low reflection and optimal performance. Compliance. Patch cords shall comply with RoHS, Restriction of Hazardous Substance, regulations to ensure they are free from harmful substances. Communication system cabinets. Communication system cabinets shall be provided to house all active and passive network components. The cabinets shall be designed for easy access, ventilation, and cable management. They shall be equipped with lockable doors, adjustable mounting rails, and adequate space for cable routing and management. Cabinet wiring details. The cabinets shall be wired in an organized manner with proper routing and securing of cables. Patch panels, switches, and other components shall be installed to allow for efficient cable management and maintenance. Cable ties, Velcro straps, and cable management panels shall be used to secure and organize the cables. Terminal blocks. Terminal blocks shall be provided for the termination of copper and fiber cables. They shall be clearly labeled and documented for ease of identification and troubleshooting. Terminal blocks shall be mounted on backboards or in enclosures to protect them from physical damage and environmental factors. Main distribution frame, MDFs. Main distribution frames shall be provided to centralize the termination and distribution of data and voice cabling. The MDFs shall be designed for easy access, ventilation, and cable management. They shall support the termination of both copper and fiber cables and provide cross-connect capabilities to facilitate network changes and expansions. Main distribution frame MDF details. The MDF shall be constructed using industry-standard 19-inch racks or cabinets. They shall include horizontal and vertical cable management to organize and route cables neatly. All terminations shall be clearly labeled, and detailed documentation shall be provided to map out all connections and pathways. The MDF shall be equipped with appropriate termination hardware, including patch panels for copper and fiber cables, punch-down blocks for voice cabling, optical distribution frames, ODFs, for fiber terminations. The MDF shall provide sufficient space for future expansions and shall be located in a secure, environmentally controlled area to ensure the longevity and performance of the cabling infrastructure. All cables within the MDF shall be routed and secured using cable management hardware such as cable trays, rings, and ties. Proper bend radius shall be maintained for all cables to prevent damage and ensure optimal performance. The MDF shall be designed to support high-density cabling installations with adequate space for high port count patch panels and other termination hardware. It shall include provisions for grounding and bonding to ensure the safety and reliability of the cabling system. In addition to the technical specifications, the SCS design shall include detailed installation guidelines, testing procedures, and maintenance practices to ensure the long-term performance and reliability of the cabling infrastructure.